In this question, it's quite typical. They give you the original function, and then there is a equation. When fx is divided by this one, the remainder is negative 24. And if you remember the remainder theorem, when fx is divided by x plus 1, that implies f negative 1 is equal to the remainder. So why it is negative 1 is, if you don't forget, is we are putting a suitable x such that our divisor becomes 0. That means negative 1 plus 1 will give you 0. So it is negative 1. Don't forget the criteria. So in this question, part A, we start from the given condition. Given that the remainder, you should write down the condition, because if you divide by different thing, then the remainder may be different. When fx divided by x plus 1, then the remainder should equal to f. Start from the given information first. They say that it is equal to negative 24. And then afterwards, the item remainder, we can get it by remainder theorem. Then we replace the item remainder by f negative 1. In your exam, if you already understand that, you may directly write down f negative 1 is equal to negative 24. It's totally fine. But for a better understanding, don't forget it, we stick to the question from the given information. And then this item, based on our learning, based on our remainder theorem, we know that it can be replaced or expressed in terms of f negative 1. So after that, what is f negative 1? That means substitution. Sub x equal negative 1 into fx. So this should be 3 something power 3 plus 20 something power 2 plus k something minus 12 minus 24. And then this is negative 1, negative 1, negative 1. And if we look at this sentence, it is a fixed value, k, fixed value. So this is an equation with k as the only unknown. That means we can finally solve what is the value of k. And if we know k, then we can find out, is this a factor, or we can find out many more. So the following mission is calculate this very carefully. 3 times negative 1 plus 20 times positive 1 plus k times negative 1. Don't make any careless mistake. Make your hand busier than your brain. Reduce the workload of your brain. So this is 17 negative k, 17 minus 12, we got positive 5. Negative k is equal to negative 29. So k itself is equal to 29. So I want you to learn is not only solving the problem, it's why we can divide step by step, lead to our answer. And then still didn't finish yet. We also need to know is x plus 3 factor. Now we already know fx is 3x power 3 plus 20x squared plus kx, but we know k already, so it is 29x minus 12. Update the information so we know a full picture about fx. And then you have two choices. You may use long division, or you may use remainder theorem to find out whether this is a factor. If the remainder, if r is equal to 0, that means this is factor. If your remainder is not 0, that means this is not factor based on our definition. That's our logic. And then so we consider when fx divided by x plus 3, the remainder, we can find remainder by remainder theorem, is f suitable x to make divisor become 0 is -3. You may rely on your calculator or get it very carefully. In part B, again, they are asking us to solve the equation, and we should start from here. Solve if x is equal to 0. That means 3x power 3 plus 20x squared plus 29x minus 12 equal to 0. And then how to solve it? To solve this kind of quadratic, not quadratic, cubic polynomials, the only method is factorization. That means you try to change these four terms into something times something. Then we can use the zero product rules. This equal to 0 or this equal to 0. So to do so, you need to use the hints provided before. X plus 3 is a factor, which we already proved in part A. So this is x plus 3. But how about if x plus 3, then what is the rest? Then we use the quotient, the long division to find it out. This is the method to find out the another factor by one factor. So 3x power 3 divided by x, 3x power 2. No remainder. That means it should be consistent with our calculation. There should be no remainder. Otherwise, it's not complete factorization. So the another factor is 3x squared plus 11x minus 4. Bing. Okay, so after that, x plus 3 is equal to 0. Or 3x squared plus 11x minus 4 equal to 0. This is like this, and then left hand side very obvious, x is equal to -3. This is one of our solution, and then we may have two more. Look here, you may use formula 1 or you may use a clause method. 3x squared -4, 3x times x, and then it should be positive 4 because the differences is quite large here, time -1, and the bigger one should be positive. So we have 12x minus 1x equal to 11x positive. So this is correct combination. 3x minus 1, the first factor, and the second factor, x plus 4. So 3x minus 1 equals 0, or x plus 4 equal to 0. X is equal to 1 over 3, or x is equal to -4. So we have three possibilities to fulfill this requirement to make this become 0. X can equal to -3, or 1 over 3, or -4. And what they say is they claim all the roots are rational number. So this is a rational number because you can write in terms of -3/1. You can express it in terms of fraction with integers only. 1/3 is, -4 also is. So all roots of equation f(x) equals 0, this equation, all the roots are rational. So agree. Irrational, that means you can express p/q, where p and q are both integers, like 1/9. This is rational. What is irrational? That means you can't express it in this way. Say square root 2, we can't express it in terms of fraction, or pi, or natural number e, some others. This is called irrational, but they are all real numbers.